So the first utility type is the awaited utility type. What the awaited utility type returns is whatever a promise returns. This is particularly useful when working with asynchronous code, but also with nested promises. For example, if I have a type B, we can get awaited from a promise of a string, which if I hover over B, returns a string. And if I was to return something like a string and a number, we will get a union type for string and number. Without the awaited, we will get the actual type itself, a promise inside of a promise. So the next utility type is the partial utility type. What this utility type does is it turns every field inside of a type into a partial type. For example, here we have an interface of our user, which has a required property of username and a required property of email. Now, below here, we have an update user function, which takes in a user and the fields to update, which is a partial of our user. If I hover over fields to update, you can see it's a partial user. Pretty much, it's turned this interface to have the optional operator before each property. So what this now lets us do is if I have a user and say I want to update a user, for example, const user2, which is going to be update user, we pass in our user1 and our fields to update is going to be something like our email, where we can pass a new email, something like mike123@gmail.com. And because the second parameter is partial, meaning everything is optional, we don't need to specify the user name. Therefore, update user, therefore user2, the username will stay the same, and the email will be updated. The next utility type we want to go over is the required utility type. Pretty much, think of it as the opposite of the partial utility type that we just covered, where every property that is optional is turned into a required property. As you can see here, we have an interface with two optional properties, A and B. Now, if I create a new object where I pass the type as a required of props, we get an error saying property B is missing in type, even though up here it says it is optional. But because we specified it to be required, we need to explicitly specify B for this to work. The next utility type is the read-only utility type. Similar to the previous two utility types we just covered, read-only turns every property inside of an interface into a read-only property. What this means is now, say we have a to-do interface and we create a to-do that is marked as read-only of to-do. This means if I now try to update any field inside of our to-do, for example, our only one is our title, and I want to set that to don't. All of a sudden, we get an error saying you cannot assign title. You cannot assign to title because it is a read-only property. It pretty much prepends everything with a read-only keyword. This is the exact same thing. The next utility type I want to cover is the record utility type. It pretty much lets you construct an object type whose property keys are keys and whose property values are of a type. This utility can be used to map the properties of another type to another type. So for example here, we have a type of roles, which is a union type consisting of either admin, editor, or VIP. Then we have another type for roles, which is a record of our role union, followed by a boolean. What this does is it creates a type where, for all of our union types, are set to boolean. What this means is that when we now create a user with, let's say, roles, or should I say, user editor, we can specify each one of these fields. The next utility type is the pick utility type. This utility type lets you create a new type based off of properties from another type. For example, say we have an interface here of a user, which contains an ID, username, password, and a creator. Now, say we just want a object where users can just update their user profile. Hence, say, for example, their username and password. We want a type for them to submit that data. We can then create a type, let's say user update profile, which consists of a pick. Instead of the pick, the first parameter you specify is the actual type that you're picking from. So for that would be user. And following are the actual names of the properties we're picking out. This can be a union type. So for example here, let's say we only want the username and the password. Now if I look at the update user profile, it's a type that just consists of username and password. This is useful as if, let's say, you pass in something that doesn't exist inside of the user interface, something like the email. As you can see, we now get an error saying that it doesn't satisfy the constraint. Following on, the next utility type is the Omit utility type, which does pretty much the opposite of what we just discussed. Let me just quickly undo this and get this code back, and say we want to do the same thing. But this time we want to explicitly specify that we don't want to include ID or creator. Pretty much the reverse logic of what Pick did. So I'll create a type, again, let's say user update profile. But this time I'll use the Omit utility type. Again, you specify the type you're creating this new type from, which will be our user, and then the properties. So for me, I want to omit the ID and the creator. If I hover update user profile, as you can see, we get the same result as from our pick, our username and password. Now with the omit, what's great is that if you add more properties and you don't omit them, they will automatically be added to our new type. Say for example, now we have an email as well, an email field inside of our application. Passing that into our interface automatically updates our user update profile, which now contains our email property, as well as the previous ones we specified. Same if we were to delete it, it goes back to where it was. The next utility type is the Exclude utility type. This utility type is only allowed to be used on union types. What it allows you to do is to remove specific values from your union that you have specified in a previous type. For example, say you've got a type of permissions. Now I want to create a new type for staff permissions, which all I want it to have the exact same as the permissions, except for we don't want to be able to delete the app. We can ban users and read posts. So to do that, we can use the Exclude utility type, passing in our permissions utility type, our union type, followed by the stuff we want to exclude. Here would be delete app. And if I hover over staff permissions, it creates a new type with just ban users and read posts. Say I want to get a user permissions, where I want to exclude from our permissions, delete app, as well as ban users. If I hover over the user permissions, as you can see, we just get read posts. Now on the other hand, we have the extract utility type, which does the opposite of what the exclude does. So instead of excluding, say I use the extract, which extracts from a from a union type. Let's say I just want to extract ban users now and read posts. If I hover that, we get ban users or read posts as our staff permissions. Of course, this is great when it comes to our type safety. If I was to add a type that doesn't exist, all of a sudden, staff permissions just stays as ban users. The next utility type is a non-nullable utility type. What it returns is it omits anything that is a nullable value, such as undefined or null. If I hover over stir here, you can see it is a type of string, as non-nullable omits undefined and null. The next utility type is the parameters utility type. What it does is it returns the function parameters from a function. For example, say I want to get a type of all foo params, which can be equal to parameters passing in foo. Now, we're not allowed to do this because we actually need to specify this as a type of, which then, as if I hover over this, we get a tuple of A being number and B being string. Now, carrying on with parameters, the next one is ConstructorParameters. This one, as you could probably get from the name, has to do with classes and constructors. So if I create a basic class, say test, and I'll delete this, and I'll create a new constructor inside of test, which will just have one parameter, A, for number, which will just do something. If I now create a new type, say I want to get a type of the constructor parameters from test, I can do type test constructor params is equal to constructor params passing in our class. Again, we do have to specify a type of keyword here. And if I hover test ctl params, again, we get A as number. This means, of course, if I update this to be bsstring and hover over this, we also get bsstring. The next utility type on the list is ReturnType. Say I want to get the return type that is returned from this function. I create a type for that, type foo return is equal to return type, passing in type of foo. And if I hover over foo return, you can see foo return is now an object type with first, second, and together, with their corresponding types. The next utility type is the NoInfer utility type. What NoInfer does is it blocks inferences to the contained type. The best way to do this is to show you through an example. Here I've got a function for colors where we have a generic type of color that extends string. Here, color is an array as our first parameter, and our second parameter is our default color. Now, if I just run this function, say colors, where I pass in red, green, and blue, and our default color, let's say it will be orange. Now, something about this doesn't seem right, because orange doesn't exist inside of our colors array. And if I hover over colors, oh, it's a bit of a mess. But as you can see over here, our type now changes of our function to also contain orange. And as you can see, inside of our colors, the array also now contains orange, as well as the default color. NoInfer restricts this behavior. So if we surround our default color type with NoInfer, with our color, as you can see, now we already get an error here, saying argument of type orange is not assignable to parameter of type red, green, blue, or undefined. Undefined only due to this here. I get rid of that. Red, green, or blue. This means this will only work if we actually specify a color that exists from our array here. For example, blue. The next utility type, following along with our functions trends, is the ThisParameterType utility type. Say a function has a this parameter, as this is completely possible, and say we want to get our parameter list. Now, have a look at this. If I create type foo params, which is, as we've done before, parameters from type of foo, if I hover over foo params, we just get bsstring. This is because this doesn't actually count as a proper type. What this technically means is it is omitted from our parameters. The only way to access this is to use the ThisParameterType, which will return the type of this, which is our interface I over here. If this doesn't exist within our function, let's see if we get rid of that. If I hover foo params, it will return unknown, as this isn't contained inside of the parameter list for foo. The following utility types are used on string manipulation based on string types. For example, let's say we have a type for greeting, which just says, hello there, sir. We can now transform this greeting type based on utilizing these utility functions. So say we've got type shout, which will be an uppercase of our greeting. Say type whisper will be lowercase of our greeting. Capitalize with type formal of capitalize with greeting. And finally, uncapitalize, say unformal from our greeting. If I now have a look at the actual types that this produces, our shout turns everything into a capital letter. Whisper turns everything to a lowercase letter. Formal turns the first word into a capitalized letter. Say if I get rid of it here, the first letter is capitalized. And unformal, which does the opposite, makes the first character a lowercase. I hope you were able to find this video useful. If you want to see more videos on TypeScript, please let me know down in the comments. And to show your support, please leave a like and subscribe on this video. It would mean a lot. Anyways, that's the end of the video, and I'll see you guys in the next one.